maybe some of you could see this 7 principles of Meteor. This was a while ago on the website of Meteor. So when developers started working on Meteor, they decided, okay, we will go with these 7 principles. First principle is data on the wire, which means we don't send HTML directly to the client, but we send data, which is then rendered on the client. Second principle is one language, which means we use one language everywhere. Java is JavaScript. We use it on the server, on the client, and mobile apps, and for the database. Third one is database everywhere, which means we can query database on the client, which was like super exciting for people. When I first saw a demo when you could insert something on the database, on the client, and then it appeared on the server, it was like pretty excited. So maybe who of you doesn't know about Meteor at all? Okay. So maybe then, firstly, a little bit introduction of Meteor. Meteor is a full stack framework. Currently, there are like 3 full stack frameworks. First of them is Mean, which you can know. But Mean is not like a framework itself. It's like a set of components, and you can bind them together and see how it works. Second one is Meteor. And third one is Derby.js. But Derby.js is in deep alpha, and it is not likely it will be there. Hello. Okay, so Meteor.js appeared like 2.5 years ago. And when it appeared, people were very excited because, oh, yeah, have a seat. When it appeared, people were really pretty excited because that time there were no alternatives to that time frameworks. It were like you could use something on the server side, you could use something on the client side, and you had to like bind these things together yourself. And then appeared Meteor, which said, okay, I'll do that for you. Why would you need that to do yourself? And when they started development, they started following these principles. So where I was, database everywhere. The fourth one is latency compensation. What does it mean? If we insert a post, normally we need to hit the server and say, okay, we are now inserting the post. Server says, okay, this post is already inserted, and then we update the view. But this feels a little bit slow, just because some time needs for round trip to the server and back. And so in the Meteor, latency compensation means that we say, okay, we are inserting post, and we display it immediately. And then in the background, we are inserting that post, and if something goes wrong, we then revert the data on the front end. Full stack reactivity means something I'll explain later. Embrace the ecosystem principle means that Meteor rather integrates libraries and frameworks into itself rather than replacing them. Yeah. And simplicity equals productivity principle means that the more simple development is, the faster you developer, and then the better it is for developer. And this is how the architecture looked like at the beginning. There was like some database sources. There were like server-side part of Meteor, which mostly concentrated on the live query thing. Then there was client data cache. And DDP was a thing that was binding 2 things together. On the client side, you had Blaze. Blaze was like client-side framework of Meteor, which was something like backbone with some template engines. You could have some app components and logic on top of Blaze. And then on top of those components, you could build web or mobile apps. So this is what was like until May 2015. starting from May 2015, a lot of things changed. And then what has changed, we will explain. So each of those principles had its drawbacks. First of all, data on the wire. Maybe you have ideas which drawbacks it could have?
About SEO?
Yeah. Yeah, definitely. So first thing is SEO. People were firstly super excited. You don't need to render HTML. It's rendered on the client side. But then you have issues with server side, with SEO. So currently, this thing can be like overcome with React server-side rendering. It's something that is coming and it will be working from the box in the later releases. How does it work? Server renders HTML, and then on the client side you get HTML and you get JavaScript files. And then those React components get bound to your HTML on the fly, and then it works. So it solves two problems. Firstly, it solves SEO optimization because Google bots can get actual HTML and then they can index it and see how it works. And the second one is it works faster because you don't need to wait all JavaScript files to be downloaded, and you can start loading HTML when you get it. The second one is embrace the ecosystem. So this principle is good, but Meteor actually didn't follow it completely. Why? You remember it has Blaze on the front end. What is Blaze? Nobody uses Blaze. People use Angular and now they use React. So what did Meteor? They added them. They added them to the system, and then you can just replace. You can use Blaze, you can use Angular, and you can use React on the front-end side. And this is first thing. The second thing is Atmosphere.js. Meteor had implemented their own package system because they found previous package system didn't work for them completely well. Hello, yeah, have a seat. Why did they do that? That time, like 3 years ago when they started, there were no one package system for both front-end and back-end. People usually used NPM for backend, and they used Bower.js on things like that for the front-end. But now, when JavaScript modules were introduced with ECMAScript 2015, it is possible to use NPM on both client-side and server-side. And so, starting from Meteor 1.3, you can use NPM as first-class package system in your apps. So this solves the problem with embrace the ecosystem. Another problem is full-stack reactivity. How do you think, what problem could be with this thing? Okay, firstly, who knows what reactivity means? Okay, can you explain? Any ideas?
If your data changes, you render your view.
Yeah, exactly. So the most easiest way to assume what reactivity is Excel file. So if we have column A, column B, and column C, and column B is calculated as some function from column A. So when you change column A, you don't need to do anything, and column B just recalculates. And so it's a really powerful thing that is used not only in spreadsheets, but in any other frameworks current, like React, Angular, and things and other. But what Meteor introduced is full-stack reactivity. What does it mean? It means that you can change this column not on the front end, but you can change it on the back end. You can change some document in the database, and then it reactively updates on the client. Did you get it? Or should I? So somehow, some magic, I don't know, some magic cats do things like they see, okay, this thing updated on the backend, and then go to your front end and they updated them. But do you know what problem this could introduce?
The run of server ends rapidly.
Yep. So if you have one user, it works perfectly and no problems occur. But if you have 1,000 concurrent users on your server and you have to, those cats have to reactively update each of those clients, this can very fast go to its limits and you have to get larger and larger resources and finally it can crash. So we'll remember this issue and we'll talk a little bit about it later. Okay, so another issue is with database everywhere. How do you think which issue could be with this principle? It's pretty obvious. If you want to maintain database everywhere, what does it mean database everywhere? You have Mongo on the server and then you have Mongo on the client. But to have Mongo on the client, you have to write your own JavaScript implementation of Mongo. And while Mongo develops, you have to add those new features to Mongo library on the client. And this is pretty difficult. I mean MDG. They implemented thing which is called Mini Mongo. And there are things like Mini Redis, Mini SQL, and other databases, but they are all incomplete. Even Mini Mongo, which is officially supported, it doesn't have, for example, aggregations on the client side because it's really difficult to implement them, and they said, okay, we'll do it later. But while time passes, you have to add new databases, for example, RethinkDB, Neo4j, OrientDB, and this is all pretty resource heavy. We'll also remember this issue. This is image which demonstrates this. So you have MongoDB on the server, but to have this ability to insert data to the database on the client, you have to maintain this Mini Mongo thing. And then they have to reactively update and synchronize between each other. Why did they do that? So that time, people used Ruby on Rails a lot, and they were pretty excited about Active Record. What is Active Record? It is a possibility. Maybe someone has a Ruby on Rails background? Okay, so I worked with Ruby on Rails myself either, and this was pretty exciting. So you had some database, and you didn't have to know any SQL stuff. You could do things like this, like you create user, you assign some attributes to it, you call save function, and this triggers actual SQL insert function. So things like that, they were pretty exciting. You can update user or delete, and this all triggers SQL functions, and you don't need to write them yourself. But this, at the end, this leads to users need to maintain this Active Record thing. Also for each of the databases, you have to write adapters for them and then to adopt them. But Meteor decided to use one database everywhere principle, and since since Mongo was the best for that time, on their opinion, they decided to use it. Okay, so the last principle that we have issue with is one language everywhere. As you could expect, if you have one database, MongoDB, and it uses JavaScript, no problem. But if you want to use SQL databases, and we have a lot of legacy applications running on SQL, you can't use JavaScript everywhere just because you need to write SQL queries. Yeah. What does it mean JavaScript everywhere? It runs on server side, which is Node.js. It runs in browsers. It obviously can run in mobile apps as Cordova or PhoneGap applications. And it was MongoDB. Hi. Okay. So I told you we already discussed fixes for Embrace ecosystem issue and for data on the wire issue. Data on the wire can be fixed with server-side routing, and Embrace ecosystem issues were fixed by adding React Angular and NPM first production support. So these three issues were in the community discussed for a while, and what Meteor development group suggested is using GraphQL. What is GraphQL? Did someone hear about GraphQL at all? Okay. Did someone maybe use GraphQL in some projects? Okay. So in most articles, GraphQL is described as replacement for DDP, but it is not actually. So to understand what it is, let's see this diagram. So what GraphQL is, it's like some layer between data sources and between actual queries that you run. You can think of it as something like active record, but it is not completely. Why? Let's see what it is. So active record was like some implementation for particular language, but GraphQL thing is language itself. So with GraphQL you can query database with various arguments. For example, here we can see user querying user model with some particular ID and fetching some fields and even fetching some nested fields. So GraphQL also allows not only query data to get it, it also allows mutating data, which means inserting, updating, deleting, and later I'll show you a demo how we can use it. But first of all, let's see what it replaces and why it can be useful. So what Facebook says about GraphQL is that GraphQL is about to replace REST. Who knows what REST is? Okay. So REST is an architecture for building APIs when you have multiple resources, like you have route users, and if you want to get particular users, it would be users/ID. If you want to insert users, it will be post request to users resource and things like that. So REST has multiple entry points, which means for every resource we have each entry point, and you have to, if you want to display multiple data on the website, you have to query each of those entry points. Yeah, have a seat. On the other side, GraphQL usually can use one entry point. And with GraphQL approach like this, you can with one query you can get all the fields you need. So you're getting here user, you're getting here profile picture, which in REST architecture you would need to do in 2 round trips. So the second thing is coming from the first one, multiple client server round trips, which I said. So here, if you are using GraphQL with client specified queries, you can fetch whatever you need in one query. So it has also other differences. You can see a little bit about it in GraphQL description. The other thing is comparison DDP with GraphQL. So DDP is used in Meteor, and it usually works through WebSockets. What's WebSockets? It's like connection, full duplex connection, which allows server to say something to the client. On the other side, GraphQL usually works via HTTP, but you can also run it through WebSockets, as I'll show you later. So DDP needs for user to define publications, what data to publish, and then on the client side you subscribe to them. On the other side, GraphQL allows you to use client-specified queries and without need to specify publications. The other thing about DDP is currently it is very tied to MongoDB. You can't easily use other databases with Meteor unless you invent some mechanism to handle the data on the client. But GraphQL is database agnostic. You can use it with any database, and it's pretty easy to add new adapters for it. Okay, so now let's go to the demo. So first thing that I'm going to show you is how GraphQL works. So if you, this is how it looks from the client side. So you can, okay. Let's remove that thing. Okay, so this is what is happening right now. I'm hitting the server with GraphQL query. GraphQL query is not like JSON or JavaScript. It's like a little bit different language, but it looks maybe it looks like JSON. So here I'm querying posts. I specify which fields I need to get, and I query nested resource, which is comments. So this is how it looks from the client side. From the server side, I need actually to define this schema. So how it is done? We have schema.js, and here in the code you would be able to see. For example, we were looking for posts. Let's see where we have. Okay, so here we define that post is some GraphQL object type, which fields it has. So field can be either string or number or another GraphQL object. Some of the fields we can resolve ourselves, so these can be custom fields. Some fields can be relation. Remember, here we were hitting comments. Comments is not a field of posts, but it's relation, and here we are like resolving this thing through, here for simplicity, comments list is just an array. So we are looking for some comments with some restrictions. The same with authors. So what can we do? This was just a query for getting comments. Okay. The other thing here is creating author. So we can create author. Okay, maybe let me show you. What I didn't say you, that GraphQL encourages you to use static types. What does it mean? You have to define for each field what type of it is. This is really great, because if you do that, on the client side, you can get all the description of your API. So this tool is called GraphQL. It is like implementation for GraphQL for testing. You can just use it for like querying GraphQL stuff, and it allows to see you all the GraphQL description just generated automatically. So each of these endpoints is previously defined on the server side, and if you do not know which queries or mutations you can do, you can just check docs, and then you can see there is create author mutation. So create author mutation obviously creates author. Let's give him ID test, and let's try to create him. Okay, so I created test author. Let's try to create him again with the same ID. So since on the server side there was specified validations, this will fail. And how can we check that we actually got this author created? We can query authors, and then we can see our author is there. Okay, what else can we do?
How these three fields appears there? You paste it, or it's automatically ID, name, Twitter? With the yellow highlighting, it just appears. You paste it, or
This?
Yeah, these three fields. When you type authors.
Yeah, it's auto-completion of GraphQL. Okay. So this query would be invalid. Because authors has fields and I have to specify at least one field. But if I don't do that...
So it's like the projection in Meteor Mongo request, right?
Yeah, maybe something like that. So what I'm currently demonstrating you is not related to Meteor for now. Yeah. But the second demo will be related to Meteor. Okay. So... Да, сажайтесь. Okay, so the other cool thing about GraphQL is fragments. So if you usually have similar requests, you can wrap them into fragments. For example, if you usually query authors and you only need to get ID and name, you can wrap this into the fragment which would have its name, and then you would use this spread operator to add this field to our query. So this way it would understand that it needs to get three fields: ID, name, and Twitter handle from here. This is really useful because if you worked with Meteor and you had to do same queries like in multiple places, you would need to either duplicate code or create your own variables. Here it is like a built-in feature of GraphQL language. You just have fragment and you can use it. Okay. And you can specify variables. For example, we can specify query which would have variable post count. For example, we want to get a few posts with title only field. So this way, this post count variable would have to be defined ourselves when we execute this query. So here I have it defined to be 2, and then this way it would be 2. If I specify it to be 3, yeah, it understands it again. Tool for writing queries, modifying data in the database without need to write any subscriptions and publications. Of course, we have to define schema, but you would need in Meteor currently, you would still need to define schema with some simple schema package or something like that if you want to have schema to be static. Okay, so this was demo about GraphQL. The other demo would be about Meteor with GraphQL. So again, just a quick disclaimer, Meteor, like when I walked to you, Meteor 1.3 version was only RC release candidate. So it is not released yet, but still these packages are already implemented, and some of them you can see. So this is demo suggested by Arunoda. Who knows who is Arunoda? Okay, so this is a cool developer. He is not from Meteor development group, but he tries a lot of cool features and he shows demos for them. and one of the demos is for GraphQL. So this app, this is a demo app. It is written fully with GraphQL without any subscriptions and publications. So how it works? This is the same GraphQL, but it works over WebSockets. So when I try to open something, some GraphQL transport method is executed, and so the same GraphQL queries we saw will be executed. Here he has some block schema defined with same fields, args, resolve functions, things like that. And on the client, he does the following. For each of the elements, he defines fragments. For example, a blog post would be some data that has this query. Is it clear for now? So this fragment for blog post would have these fields, and it would have comments. And comments will be also fragment, which is defined within comments component. So comment has author, and author is fragment, which is also defined within author component. So this way you do not duplicate data, and you just reuse it, which is pretty cool. And you do not need to version your API if you want to add some new field. Do you know what's API versioning? For example, you had some public API, and then at some point you change it, but you still have clients who use previous version. What do? You can't throw it away. You keep old version and you add new version. But if you are using GraphQL, you don't need to maintain those multiple versions. You just can add on the client side new field to the query, and you get it on the client. So yeah, this is the demo of GraphQL here. Arunoda has released package, which is called GraphQL, I believe. And with it, you can run these queries, these test queries in GraphQL on your Meteor Mongo collections, and this will work. So yeah, this is all regarding GraphQL I have. Maybe you have any questions? Okay.
You just showed the demo with GraphQL, and I saw the extension of file, it was JS6.
Yep.
Does it mean that it's better works with the React ecosystem, either the Blaze ecosystem?
Yep.
Can I use it from the Blaze?
Yeah, you can use it from Blaze because GraphQL doesn't depend. It's like data layer. It's not dependent on Blaze or React. But since in future versions it is likely that Blaze will be deprecated and you will have to move either to Angular or React, then Arunoda decided to show it on React. But yeah, definitely you can use it with some Blaze stuff.
Okay. Second one, why they suggest to use a HTTP request firstly? Because sockets, it's more efficient way to communicate between.
Okay, so this is a really good question. So we had this slide. Yeah. Full stack reactivity. Why do they decide? Why do they suggest to use HTTP first? Because usually you do not need to update all the stuff reactively. For example, if you have a blog post page, of course you would need to update comments if they appear. But do you need to update reactively, for example, date post was created. It is not likely it will change at all. Do you need to update reactively header of the website? Of course not. So there are a lot of things that create production resources overhead, but they are not needed. So they suggest you to use it when you need it. MDG calls it controlled reactivity. So when you need reactivity, you can use reactively things. If you do not need it, then cool, you can just create HTTP request, get it, and forget about that client.
So if you need it, you should use two ways, the HTTP and the sockets.
Or one of them. You can also use only one of them. If you prefer everywhere to use reactive stuff, you can still use it. But now you have option not to use it. Previously, it was not that easy not to use it. So I saw even demo, and there one guy saw how he was fixing an issue. So he had a lot of requests to the server, and then he just made a few subscriptions non-reactive, so which means you just get data and you forget about them. And he fixes the issue because he still can handle all the other reactive subscriptions, but he has them like 5 times less. So yeah, this is for that. Okay, a question?
Does the X ready for production?
Good question. So Kadira, which is a website of Aeronoda, uses a lot of things he discusses. So it uses GraphQL. It uses React server-side routing and React server-side rendering. So things that are not considered yet to be production ready, they do use them, and they say it works very, very cool for them. So currently, when we learn them, I think tomorrow we will be able to use them in production apps, and so no problem.
But MDG group will make Apollo.
Yep.
But it is just some kind of plan.
Yeah. So Apollo is likely to replace current subscription system. It is true. So Apollo will be based on GraphQL. So the demo I showed to you, it is not based on Apollo, just because Apollo wasn't released yet. But we still have GraphQL stuff in Meteor, and we can use it for now like this. When Apollo is officially released, yeah, it is likely that you would definitely need to move to Apollo.